to spectacular new images from the James Webb Space Telescope, the stunning and intricate details of a star-birthing region in the Triangulum galaxy. The pictures feature the star-forming region NGC 604 located in the Triangulum galaxy 33, which lies roughly 2.7 million light-years away from Earth. This discovery, according to the space agency, is special because it hosts the newest of stars, and there is no such region in our very own Milky Way galaxy, according to estimates. The NGC 604, around 3.5 million years old, and it spans 1,300 light-years across. The region contains over 200 of the hottest, most massive types of stars, all still relatively young. The stars in question are B-type and O-type stars, the latter of which can be over 100 times the mass of our Sun. Dusty regions of space, like this one in the Triangulum galaxy, can be difficult to study in visible light, as optical telescopes can't peer through the cosmic dust. But the Webb telescope's infrared view of the Triangulum galaxy enables astronomers to peer through the dust and get a closer look. Webb's NIRCam view of the Triangulum galaxy region shows bright red dusty tendrils and clumps of emission. This two-part graphic shows evidence of a gaseous clump of helium and the halo surrounding galaxy GNZ11. In the top portion, at the far right, a small box identifies GNZ11 in a field of galaxies. The middle box shows a zoomed-in image of the galaxy. The box at the far left displays a map of the helium gas in the halo of GNZ11, including a clump that does not appear in the infrared colors shown in the middle panel. In the lower half of the graphic, a spectrum shows the distinct fingerprint of helium in the halo. The full spectrum shows no evidence of other elements, and so suggests that the helium clump must be fairly pristine, made of hydrogen and helium gas left over from the Big Bang, without much contamination from heavier elements produced by stars. Theory and simulations in the vicinity of particularly massive galaxies from these epochs predict that there should be pockets of pristine gas surviving in the halo, and these may collapse and form population 3 star clusters. These infant stars emit intense radiation, especially over ultraviolet wavelengths, and blow out powerful stellar winds that carve out cavities in the NGC 604's gas content in the MIRI and NIRCam images. These cavernous voids can be seen as huge, dark bubbles surrounded by wispy tendrils. In the NIRCam image, tendrils of gas are prominently seen as bright red threads extending from those voids. A ghostly blue and white glow around these tendrils is the result of ultraviolet light ionizing hydrogen gas. Bright orange streaks in this NIRCam image indicate the presence of carbon-based molecules called polycyclic aromatic hydrocarbons. This is significant because pols play an important role in forming both stars and planets, and are considered important building blocks for a life here on Earth. However, where pols originate remains a mystery. Further from the dark voids are deeper red clouds, which signify the presence of unionized molecular hydrogen. It is in this cooler gas where stars are more likely to form, spotted throughout the NIRCam image, bright blue stars in the process of creating voids of their own. A second image of NGC 604, captured by MIRI, shows the region in mid-infrared wavelengths. This view includes fewer stars, because hot stars emit much less light at these wavelengths. While the larger clouds of cooler gas and dust glow, the Webb team said, the image also captures some stars from the surrounding galaxy, called red supergiants, which are cool and very large. It's quite rare to find this concentration of them in the nearby universe. In fact, there's no similar region within our own Milky Way galaxy, the Webb mission team said. The Triangulum galaxy, at 2.73 million light-years from Earth, is considered nearby because of its relatively close distance, and because Triangulum's star-forming region is so concentrated. The data collected by Webb to produce these new images has allowed astronomers to begin studying the stars as newborns. The Webb team called this a fascinating time, as the process of star birth is still one of the most mysterious and complex phenomena in the universe, despite also being a popular subject of scientific investigation. This concentration of massive stars, combined with its relatively close distance, means NGC 604 gives astronomers an opportunity to study these objects at a fascinating time early in their life. How stars are born and how they interact with their environments are two big questions in astronomy today that are actively being studied with the Webb telescope. In these new images, Webb is showing us parts of the story of star formation that we could never see before, revealing more about the universe and our place in it. The James Webb Space Telescope is the largest, most powerful telescope ever launched into space. It follows in the footsteps of the Hubble Space Telescope as the next great space science observatory, designed to answer outstanding questions about the universe and to make breakthrough discoveries in all fields of astronomy. The James Webb Space Telescope is an ambitious scientific endeavor to answer these questions. Webb builds on the legacy of previous space-based telescopes to push the boundaries of human knowledge even further, to the formation of the first galaxies and the horizons of other worlds. It is a joint project between NASA, the European Space Agency, and the Canadian Space Agency. The primary scientific objectives of the JWST include studying the early universe, galaxy formation and evolution, and the formation of stars and planetary systems. The telescope is also used to study the atmospheres of exoplanets to search for signs of life. The JWST is positioned at the second Lagrange point L2 of the Earth-Sun system, located about 1.5 million kilometers away from Earth, and uses a 6.5-meter primary mirror to collect and focus infrared light from the most distant objects in the universe.